In this video, we are going to talk about the spherical coordinate system. So, from the previous video I did on the coordinate system, that's the three-dimensional coordinate system, which we talk about the cylindrical coordinate system. With this is a spherical coordinate system. So, with spherical coordinate system, it's another way to represent the points in 3D. In 3D plane, whereby 3D means that r is plane 3, is by using the spherical coordinate system. It's the easiest to sketch. So with the coordinate system, we have you changing the Cartesian coordinate system into the spherical coordinate system, right? So we have the rho, theta, and phi. So with the spherical coordinate system, we are dealing with rho, theta, and phi. What about the cylindrical coordinate system? We deal with what? R, theta, and z. So this is how we sketch. When you're sketching the x, this is the x, y, z plane. This angle here represents the phi, and this also represents the theta, and this represents the line distance from here represents the rho. That's all. So with this, you can derive your formula from here. With the formula, how do you get it, right? Yes. So let's move on. So at the end of this video, you'll be able to convert the cylindrical coordinate system into the spherical coordinate system, and also convert the Cartesian coordinate system to the cylindrical coordinate system, the spherical coordinate system. But in this case, what I want you to know is that whenever they give you the Cartesian coordinate system and they ask you to convert it to the spherical coordinate system, first you need to change it to the cylindrical coordinate system. Then you work from there. Thank you very much for listening. So we have something here that the spherical coordinate system consists of the following three quantities. We have the rho, which is the distance from the origin to the point, and we assume that the rho should be greater than or equal to 0. We have the theta, which we can get that using the cylindrical coordinate system, because when you convert the Cartesian coordinate system to the polar coordinate system, you're going to get the theta from there. That's why I told you that whenever they give you a Cartesian coordinate system and they ask you to change it to the spherical coordinate system, it's advisable for you to change it to what? The cylindrical coordinate system. Then you take from there. Then we move on to the phi. The phi is the angle between the positive x-axis, the positive z-axis, and the line from the origin. And it's between 90 to what? 180. That is phi. So we have some relationship that I want to give you here. So some relationship that we need to know. From proving the formula, what is necessary for us to know is that z in this case is equal to what? Rho cos phi. And in this case, you can also make from here, and r is equal to what? Rho sin phi. So you can just, if you want to find phi, you can say cos phi is equal to what? Z over rho. And find the cos inverse, and you are good to go. You get the what? The phi. The same thing applies to this. So in the equation, when they give it to you, you can use cos phi is equal to what? Z over rho. And you find the cos inverse of the z over rho, and you get the phi. As simple as that. Now in this case, this is for the Cartesian plane. You change the cylindrical coordinate system to the spherical coordinate system. They'll give you r, theta, and z. For you to, r is equal to what? Rho sin phi. Theta is the same as theta, and z is equal to rho cos phi. So from these three things, you'll be able to get it very simple. So from the Pythagorean theorem, you're going to know that our rho squared is equal to r squared plus z squared. And in this case, we also get that rho squared is equal to r squared plus z squared, whereby the r squared now represents what? X squared plus what? Y squared. So in this case, when you substitute all together, you're going to get that rho squared is equal to what? S squared plus y squared plus z squared. And next, we find the Cartesian plane at the same point. So we know that as I told you that for you to change the Cartesian plane to the spherical coordinate system, you need to first change it to the cylindrical coordinate system from this formula that we proved from the cylindrical coordinate system. So then we do some substitution, right? After the substitution, we know that you're going to get that x, because r is what? P sine phi, and it's what? Cos theta is going to be P sine phi cos theta, and y2 r is what? P sine phi sine theta, and z is equal to what? P cos phi. So this formula is just simple because we are representing here by r, and we know this formula already by getting this. But we know that rho squared is equal to what? R squared plus z squared, whereby r squared is equal to what? X squared plus y squared. So we get that. So that is all about the spherical coordinate system. So let's do one example. So we are supposed to convert this. This is a cylindrical coordinate system to spherical coordinate system. This is r, this is theta, and this is z. So we need to convert that. So first, what we need to do is that we need to find the angle. The angle now we have here is pi on 4. So we have the angle, but let's find our rho, whereby rho is equal to the square root of what? R squared plus z squared. They gave us our r from the question. They gave us that our r was root 6, right? And our theta is pi on 4, and our z is root 2. So then you do it. Our our rho will be what? The square root of r squared plus z squared, which will give you root 8 2 root 2. Then you find our phi. You know that phi, I told you that z is equal to rho cos phi. So therefore you make cos phi the subject and find the inverse. So when you make cos phi the subject, you're going to get z over rho. And we know z given to us, and we know the rho. We just find the rho. Then we are going to find the phi as well, the cos inverse of what? The z on rho, and we are going to get pi on 3. And that's all. And then we know that our theta is the same. As simple as that. So this is